Welcome to the MecSoft Student Project Series, where you can find real students in academia using MecSoft products in an educational setting. Today we'll see a composite marine steering wheel project created with the help of RhinoCam by student Simon Pride at IYRS School of Technology and Trades in Newport, Rhode Island. IYRS School of Technology and Trades is a nonprofit post-secondary experimental learning school located in Newport, Rhode Island. The school offers education and training programs for craftspeople, artists, fixers, technicians, thinkers, problem solvers, and creatives. The school is located on Aquidneck Island, whose yacht-filled harbor once hosted the America's Cup, a renowned annual sailing regatta for many years. The school's alumni are rapidly employed into the local shipbuilding industry, which helps make Newport one of the most popular lifestyle and tourist destinations on the New England seacoast. Composites technology. Composites are broadly defined as materials in which a binding agent, such as resin, is reinforced with a strengthening material, such as glass or carbon fibers, within a mold. Kelsey Britton is the Composites Technology Program Manager and instructor and considers shipbuilding to be more of a way of life rather than a job. Her mother taught Kelsey how to sail as a child. Her brother is a ferry boat captain in New London, Connecticut, and her father is a career marine mechanic and manager. Kelsey started her career in hospitality, doing everything from bussing tables to managing entire restaurants. Soon, however, the love of the boat-building trade urged her back home, where she enrolled and excelled in the school's yacht restoration program. Kelsey made such a positive impression on the staff that in no short order she was offered and accepted a full-time position to teach at the school she loves. We recently sat down with Kelsey to discuss her use of RhinoCam as part of her curriculum in her Composites Technology class. Here is some of what Kelsey Britton, Composites Program Manager and Instructor at IYRS School of Technology and Trades, had to say about her RhinoCam.
A lot of the stuff on MecSoft website, like all the support on all the blog posts and stuff, has been really helpful. I do like how every time I go back into it and there's more information and there's more, like, if you hover over this, a little bubble pops up, and I feel like every semester there's more access to support, and that's huge for me.
Thanks, Kelsey. The Marine Steering Wheel Project. In this project, student Simon Pride designs and manufactures the marine steering wheel shown here in Rhino, using composite technology materials and techniques. Simon used the positive 3D model of the steering wheel to split and subtract the cavity to design the upper and lower mold blocks. The design consists of the main steering wheel that is 25.4 millimeters in cross-section and 445 millimeters in outer diameter. The center connecting spoke is 6 millimeters thick and blends into the main wheel at both ends. The central parting line lies on the XY plane. 3-axis Z-level roughing in RhinoCam. On the left, we see the bottom cavity mold half for the steering wheel. The view shows where the center spoke transitions into the outer wheel. On the right, we see the cut material simulation and in-process stock left after a 3-axis Z-level roughing toolpath using a 3 millimeter diameter end mill. The cut parameters include a stock allowance of 1.259 millimeters, an offset cut pattern, mixed cut direction, an inside start point, and a 40% tool step over. For cut levels, a step down distance of 2 millimeters and a maximum top Z height of 50.8 millimeters. The clear flats option is also checked, which ensures that a cleanup finish pass is located on the floor of the spoke cavity. The 1.259 millimeter stock allowance ensures that only the vertical sidewalls of the spoke need to be finished. 3-axis Z-level finishing. Two 3-axis Z-level finishing operations are performed using a 3mm diameter ball mill. The first finishes the outer wheel cavity, and the second finishes the inner spoke cavity. This is followed by a 3-axis pencil trace operation using the same 3mm ball mill as a finishing pass. It calculates the bitangent path between the spoke floor and the drafted spoke sidewalls. On the right, we see the right side image of the actual mold haft after being prepared for composite layup. Here we see student Simon Pride preparing his composite marine steering wheel for assembly. With assistance from IYRS staff, Simon submitted his unique design to the U.S. Patent Office for consideration. Way to go, Simon! More about IYRS. IYRS School of Technology and Trades, located in Newport, Rhode Island, offers marine industry classes on composites technology, marine systems, boat building and restoration, as well as digital modeling and fabrication. To learn more about the IYRS programs, we invite you to visit them online at iyrs.edu, as well as on Facebook, Twitter, and Instagram. RhinoCam is available in 5 configurations: Express, Standard, Expert, Professional, and Premium. The parts shown here were programmed using the Professional configuration. Here are some additional details about each of the available configurations. For the complete features list, we invite you to visit the RhinoCam product page. See the link in the description below to download your RhinoCam today. We want to extend a special thanks to Kelsey Britton and the IYRS School of Technology and Trades for allowing us to showcase their work. This video was brought to you by MecSoft Corporation, your CAM partner.